The second lecture slide shows where comets come from. There are two basic types of comets. The long-period comets have very elliptical orbits with periods of hundreds to millions of years and orbit sizes of 50 to 100,000 astronomical units. They come in randomly from all different directions. With such long orbital periods, their presence in the inner solar system is, for all practical purposes, a one-time event. Yet we discover several long-period comets every year. This implies the existence of a large reservoir of billions to trillions of comets called the Oort cloud, after Jan Oort, who deduced its existence. At the great distances of the Oort cloud, comets can be affected by the gentle gravitational tugs of nearby passing stars. The passing stars tug on the comets, perturbing their orbits, sending some of them into the inner solar system. The Oort cloud comets probably formed 4.6 billion years ago at about the same distance as where Saturn and Uranus are today from the Sun, and were then deflected outward when they passed too close to the large planets. Comets forming at the distance of Jupiter were either ejected from the solar system by the massive comet in a gravitational slingshot or gobbled up. Comets forming further out than Neptune's current position never coalesced to form a planet and now make up the Kuiper belt. That leads us to the second type of comet, the short-period comets, which have periods less than 200 years and orbit sizes of 30 to a little over 100 astronomical units. Their orbits are roughly aligned with the planet orbits. Gerard Kuiper proposed the existence of a disk of hundreds of millions of comets from 30 to 100 or more astronomical units from the Sun, orbiting roughly along the ecliptic. This is now called the Kuiper belt. We have now directly observed comets that remain in the Kuiper belt with more circular orbits, whereas the Oort cloud was formed by gravitational slingshots of comets that were close to the Jovian planets in the early solar system. The Kuiper belt comets are the leftover chunks that formed in the outer solar system and didn't get their orbits messed up by getting too close to the Jovian planets. Dwarf planet Pluto and its moon Charon are large Kuiper belt objects that are large enough to make themselves round and have really interesting geology. See the textbook for more details about that. The last part of this lecture slide talks about meteor showers, which form when the Earth plows through a dust trail of a comet bits left behind as the comet orbits the Sun. Short-period comets make hundreds to thousands of passes around the Sun, spewing out gas and dust. Over time, a comet will leave bits of dust along its orbit. Each piece of dust has an orbit close to the comet's orbit. The dust grains are the size of a grain of sand or smaller. If the Earth passes through the comet's orbit, the dust grains can hit the Earth's atmosphere to make the spectacular displays called meteor showers. After many passages around the Sun, the nucleus has no more volatile material and it becomes dead. Some asteroids, in fact, are former comets. The meteors in meteor showers are tiny bits from comets, fluffier than the regular or normal meteors, which are chips of asteroids. Normal meteors are a bit larger in size and usually move slower than the meteor shower comet bits. As the Earth plows through the dust trail, the meteors appear to streak out of the point called the radiant that the Earth is moving towards. It's the same converging lines perspective effect you see when you look down the length of a long, straight railroad track or road. The textbook has a table of the major meteor showers and their parent comets.